Hello and welcome to the SC Launch and Learn with Noah Gresham and Dr. Singh Anand of Tatras Data. Today we are talking about the future of data. Before we begin, I'd like to go over two housekeeping items. First of all, if you can hear me, please raise your hand in the webinar controls. Thank you, Jim, Thad, Tom. Thank you all for joining us. You can go ahead and lower your hand down. Secondly, I'd like to just take 30 seconds to talk about the format of today's webinar. We will keep all participants' audio muted. So if you have questions, please feel free to type them into the webinar controls at any time. Then we'll go ahead and we'll pause 20 minutes in for some Q&A. And then again, we'll have a Q&A period at the end. I will be reading the questions out loud, and Sarah or Noah will be answering them. With me here today in our webinar studio is Dr. Singh Anand, who has worked in academia for the last 20+ years, teaching, developing, and applying data science algorithms to real-world problems. Joining him is Noah Gresham. Noah is a serial entrepreneur with over 25 years experience creating and developing tech-driven businesses. My name is Julia Linton, and I serve as the operations manager for SC Launch. Noah and Sarah, thank you so much for joining us. I'd like to hand the mic over to you guys.
Thank you, Julia. Thank you. It's great to be here, and I look forward to our interaction with all the attendees. What Noah and I want to talk about today is the impact of data and AI on business. A little bit of background to our company, Tatras. We are a consulting and software development firm focused in the space of artificial intelligence. We provide clients with strategy and implementation services to help drive business transformation and innovation. With that in mind, we wanted to talk to you about why this webinar is important and why you should be listening in on this. You probably heard a lot about the fact that we are exploding with data today. We've got very good at generating data. The question now is, how do we utilize that data to benefit from it as a business? We're also seeing terms like cloud computing, the power of data and its application, specifically using artificial intelligence to impact business efficiencies. And of course, another term, and this is only a selection of all the terms you're coming across now, so there's a lot of innovation happening in this space. The idea of blockchain, the distributed ledger, that is, again, a very impactful and disruptive technology that's on its way. Specifically, we're going to focus on the fact that there's a lot of data out there that your business can leverage, whether it's internal data resources or external, and how do we actually use that data then using technology from machine learning and artificial intelligence to impact the data. If you haven't started using artificial intelligence within your business, you're not alone. Today, a recent survey by Gartner showed that only 14% of businesses are currently deploying AI. However, an important consideration is the fact that Gartner's survey also suggests that that number is set to go up to 50% by the end of 2020. So businesses are standing up and taking, paying attention to this new technology of artificial intelligence. And 75% of businesses are really looking at AI because they fear disruption that could be caused by data-driven competitors. And that's another 2019 survey, so a very recent survey by New Vantage Partners. So there's definitely this feeling within business that there is a competitor around the corner, there is disruption around the corner that is going to be data-driven and is going to be using artificial intelligence to become more efficient in doing whatever business we are in today. So for all sorts of sectors, and we look at a number of case studies throughout this webinar that give you some flavor of how AI is being used. Noah, did you want to add?
Yeah, I was just going to add that what we're seeing is the interest level for AI and the impact that it's going to make on different business models is really happening across multiple domains, from manufacturing all the way through to technology. So there's not a silo, it's really happening systemically.
So the AI, of course, is not a new topic. For those in academia, the roots go back to 1956, not long after computers came into being, right? So the initial applications of computers were all around being like a calculator on steroids of kinds, where you could actually do a lot of difficult computation and maths. But there were a bunch of researchers back in 1956 that actually started thinking about how can we make this machine more intelligent. So the research was driven by their desire to understand intelligent behavior within humans and to emulate that within computers. And the basic definition of intelligence, of course, we can probably have a philosophical discussion around that for hours, if not years. But specifically, I'd like you to think about, intelligent behavior is the ability to learn, to be able to adapt to your changing environment and get better or more proficient at what you are doing. Right? So these are key human elements of learning. If we look at the evolution of artificial intelligence from 1956, there were a number of streams of thought. Some of the individuals involved in artificial intelligence looked at natural processes to model artificial intelligence within machines. So they started looking at the human brain and how does it function. Of course, we didn't know a lot about the human brain at that time, so they came up with some simplistic models, and the work of neural networks actually dates back to 1958. So again, a long time ago. Other researchers started looking at the whole evolution of humans and Darwin's theory of evolution, and started looking at whether with the concept being that every generation is optimizing itself to deal with nature, can we actually model that? And so genetic algorithms was again another area of research. Other mathematicians who were involved were looking at things like logic. And soon they started finding deficiencies in logic because, of course, as we all know, humans need not be very logical, but are still very successful in dealing with their environment in the real world. So that led to models of dealing with uncertainty and, Bayesian models that came along in the 1980s. And as we progressed through, a number of these models failed to deliver on the initial promises that were made. And so we did have regions of our history where we refer to it as the AI winter, where essentially people started giving up on artificial intelligence. But it was because of researchers that had actually a great belief that they can work on methods that can make computers more intelligent and can reproduce some human behaviors that are considered intelligent. They continued to research on this. And it was in 1991 that we actually saw AI making its first foray into the industry with, it was termed not as data science at the time, but data mining. And I was lucky to get involved in the very early stage of that and see how some of these algorithms could graduate from the laboratories and actually start making an impact. And if we look at the last, 10 years, what we've seen is the neural networks, a lot of the ideas had their genesis back in the 50s, and through the next few decades after that, they have now started delivering real value. So if you've gone to Google and tried to translate a sentence from English into French, you'll see that you're actually doing a much better job today of it. So we are seeing a lot of AI that is now impacting our lives, whether we go to Google and search on Google, whether we are looking for interactions on Netflix, how Netflix is actually presenting content to us that is much more related to our preferences than we would have exposed to them, over our interactions. So, if we look at basic intelligence, humans learn through experience. When a child is born, from that point on, he's experiencing his environment or her environment and is learning and creating a kind of a knowledge base within their brain that they utilize to interact with the environment more efficiently. Artificial intelligence also works the same way. And when we think in terms of what is experience to an algorithm or a machine, well, it's data, right, about whatever the experiences that the machine is being exposed to when modeling a business. So when we think about the building blocks today within AI, we think of three basic important components to it. You've got data, and you would have heard terms like relational databases, big data, the three V's of big data, the fact that we have great volume, velocity of the data that's coming through to us, and the variety of data that's available. We then utilize that data with algorithms, and again, you may have come across some of these terms. Definitely, deep learning is something that's talked about a lot in the media because there are, a lot of developments that have taken place with deep learning that are impacting our lives today. The fact that, in medicine, doctors are actually getting less efficient compared to algorithms in diagnosing medical images. And there's talk about radiology being done by artificial intelligence in the future. But building these models themselves is not an end, right? We have to make sure that those algorithms that have been developed can actually be deployed within the business. And so a very important aspect of actually venturing into artificial intelligence is to say, what's the problem I'm trying to solve? How am I going to solve that? And how am I actually going to deploy that solution that's being generated? And one of the key drivers for our ability today to do artificial intelligence is the computing power that's being generated. So while these ideas are old, the implementation of that has been made possible by GPUs and TPUs, which are the hardware that these very complex algorithms run on to crunch through the data and actually produce value for business. Now, what's true for humans is also true for business. Today, businesses have to deal with a lot of changes that are taking place. There's technology innovation, there's globalization of markets and competition, and there's process automation. How do we deal with these? How do we actually make sure that the profitability of the business, which is under threat, can be sustained by the business? And really the solution is to leverage the data assets that the business has. So just as humans, businesses also need to become learning organizations and utilize their experience, which is essentially hidden in the data that you have gathered from your interactions with your customers, to utilize that and innovate with artificial intelligence. From a business perspective, there are two aspects to this. One is the management challenge. C-level executives need to understand and strategize as to how all of these new technologies like AI and data can be leveraged to deliver on what is going to be their vision for the business in the next few years. They've got to invest in innovation. It's more about building a culture of innovation within the organization that the focus needs to be on. From a technology challenge perspective, what businesses are finding is they don't have the infrastructure for running these kind of artificial intelligence algorithms, or they don't have the skills, or both, in fact, right? So very often you have businesses that have built up skill sets that can deliver on their operational needs, and manage their IT infrastructure. But when it comes to artificial intelligence, it's a whole new skill set that needs to be developed. And rather than jumping into it and trying to hire AI experts into the business, I think a much better approach to take is where you actually work with businesses that can have already got those skill sets and can help you see value before you actually invest. And that's really what we have done with a lot of our clients. So, that's been a lot to take in, I think, at this point. And obviously, what we'd like to do now is to look at a real-world example of how do we bring all this together, right? So let's take a very simple example of an e-commerce player that we worked with a number of years ago. They were in the office and printer supplies business. They had offices in the US and as well as in Europe. And were a successful organization until they started finding that there was an increasing cost in acquiring customers. Their main channel for acquiring customers was paid advertising at the time. There was a low barrier to entry into the market, and so they had a lot of niche competitors come in that were pricing lower than they were, and as a result, there was reduced profitability. Of course, Amazon was having an impact on their business at the time as well, as it grew into the tiger that we see today. And on the other hand, the business that they were primarily in, which was printer supplies, the market itself was shrinking. Now, what they did realize was that they had a lot of data assets. They knew, where they were acquiring the customers from. They knew, how much these customers were transacting with them. They had, data on how are their customers engaging on the website, what are they looking at. And so the first thing we did was all of this data was sitting around in silos. So as we mentioned in the previous slides, the starting point is to create a unique data asset, right? So we pulled all of these data sources together. We actually enhanced that data by looking at the external data sets that are available that provide you demographic characterizations at a zip code level, for example. We added that into the data and created this asset, right at the center of this wheel that you can see. We then started looking at what sorts of problems or what are the areas where we can produce optimization. So if we look at an e-commerce business, they've got competitions. They obviously need to keep in line with the competition on pricing and how they project their customer service, how they project the products that they sell. At the same time, they've got to look at processes around customer acquisition. How can they make those more efficient? How can they retain those customers and engage with them so that they can bring down their cost of retransaction? And then finally, they have a supply side at looking at, where do they acquire the products that they're selling, what's the cost of goods, and how can they deliver to their customers at the lowest cost possible to maximize profitability. And we found that each of these can be impacted with AI. So the first thing we did was to say, well, a customer must have a lifetime value. How can we predict that lifetime value given the interactions we've already had with those customers? We then looked at how do we actually acquire those customers that have a higher projected lifetime value. So it's not just about acquiring more customers. Of course, more customers is good, but acquiring good customers that are going to generate a lot of profitability is going to be really important for the business. And so we changed their whole strategy of bidding for paid advertising, and that's the deployment side that we talked about earlier, right? So the data has been collected. We've built models around customer lifetime value. We've built predictive models to figure out as to whether certain paid advertising opportunities should be aggressively followed or not. And then we've actually plugged those algorithms directly into the bidding process to make sure that in real time we can start making decisions about where should we be investing our money in acquiring customers. And similarly on the supply side, we were able to build what's called least cost fulfillment, where we were saying, once an order comes into the e-commerce business, how do we actually split that up into sub orders and give them to our different suppliers to drop ship the product, so that we can reduce the total cost of delivering on the order that we received from the customer, and therefore increasing our profitability.
Yeah, Sarabjot, I would just add this project specifically and other projects that we've had success with, the key ingredient was deep domain experience, understanding from the business side what the problems were and the problems that needed to be solved to make an impact, and then connecting that to folks, and in this situation was Tatras Data, that could help translate those problems into meaningful, realistic results.
So at this point, I guess we'll pause for some questions.
Great, thank you so much. We'll let you get a sip of water, and we will open up the line for questions. If you want to go ahead and search for your questions area in your webinar controls. We will wait for those to come in, and we will. I'll go ahead and read them out loud, and Sarah and Noah will answer. All right, so while we're waiting for some questions to come in, I have a question for you. What is your ideal person to pick up the phone, call, and say, hey, I need your help? What is that like perfect client kind of look like for Tatras Data?
Well, I mean, from a client perspective, we're domain agnostic, so the transformation is happening throughout many domains and many ecosystems. So I think it's typically somebody who's at a C or upper management level that's really looking at the strategy for the business and how to remain competitive and to scale their business in a very positive way across the timeline. And that person sometimes comes out of marketing, that person sometimes comes out of the C-suite, sometimes from technology, but it's a wide range of folks.
Is it someone that is it a company that's already collecting data? Or is it a company that's like, hey, I think I've got a vehicle to collect data. Could you help me?
It's both really. I mean, we have worked with companies where they're hearing a pull from the market. So technology companies that have a platform, and they're hearing from their customers that they need a certain kind of feature, which they don't have, which is related to, some kind of adaptability, for example. So we worked with, to give you a concrete example, we worked with an education company that had a platform for delivering content at a distance to customers, to students. And the customers kept coming back to them and saying, can you adapt the content to what the customer is and the student is learning, right? And they had no idea of how to do this. So we actually engage at that point as well with a business to help them create that vision and give them an understanding of how do you actually, what are the data assets you have is the first question. The next one is, we think about what are the data sets externally available that we can bring in and enrich and then utilize to deliver that requirement, right? And then we actually have them do a POC and actually see the value of what can be delivered with that data as well.
Excellent.
But at the same time, it could be somebody who actually has a real problem in their business, has data, has some understanding of, from attending seminars, knows that AI has been used here, but don't have the internal resources that are available to actually deliver on that vision. So when they have a complete vision, we're quite happy to engage on that also and deliver on that. And sometimes those are the easier clients.
And we also have, very startup oriented folks that come to us and say, in the beginning, can I create a data asset that will solve this problem? And we do it from scratch with them and do the vetting and are able to do that front end piece as well.
Excellent. Thank you. So we've got a question that has come in. The question is, cities and municipalities are managing a lot of data of their citizens, businesses, and visitors. Should these cities own this data? How should they best manage it, and how can they monetize it?
Do you want to take that?
Go ahead. You can take a start.
Well, definitely they should own that data. From most businesses today are data companies, whether they have a different front to them, right? So there've been all sorts of quotes like data is the new oil and all that kind of stuff. But the truth of the matter is it's a huge asset. For municipalities, of course, they can create a lot of efficiencies in running their processes, their services to their citizens. And I think that's where the focus has to be. We are giving a lot of data to private businesses today. Google knows more about us than we know about ourselves in many ways. Compared to that, I think municipalities are more friendly in the long run. They've got to leverage that data, provide better services for us, and it can have a direct impact on the tax we pay, right? Because they get more efficient and can do things cheaper. That should be able to impact our tax bills to them. So I think it's very important for them to leverage data.
And for their own optimization purposes, but also there's a business component, and I'm not sure from the legal perspective how it works, but a lot of organizations would love to have access to this type of municipal data in packages. I can think of real estate where we're trying to predict maybe price and these types of things. So there's a lot of data that could be utilized in outside services as well.
Yeah, absolutely.
Great. Thank you so much. We've got another question that just popped up. The question is, what are the top cybersecurity issues for responsible data management? And how does the average IT professional address data and cyber management for their employees?
Actually, the best way of dealing with this is to have the data on the cloud. Today, the AWS and Google have better security systems than we can really build and manage ourselves. They've gone through all the exercise of making sure that they have, certification for even storing medical data today. So in my view, actually, cloud services are probably the best way to go. If you, obviously, you want to make sure that that data is secure, both at rest and when it is actually traveling across, right? So when we actually send data across the internet, we are making sure that it is secure. The problems there are that, when people come onto your server, you want to make sure that they can't utilize the data that they get access to. There are, unfortunately, very good hackers that are out there, and we hear stories of how people are exposing their data. Really, the only thing we can do is to use cryptography to, protect that data and make sure that we don't make it accessible.
Great, thank you. All right, Catherine, it looks like you have raised your hand, but unless you type a question in, I won't be able to call on you and open up the line for you to vocalize your question. So go ahead and type that question in, and we will address that. But if you're not interested in typing a question, we'll go ahead and move forward with the webinar. I'd like to invite everyone to continue to type your questions in, and we will address those at the end. So, Sarah, Noah, after you.
Great, thank you. So we thought we'd go through a couple of use cases in different domains to give you an idea of kinds of applications that are out there. One very interesting application that we worked on for a European wind farm was to look at predicting the amount of energy that they were producing, or going to produce actually the next day. When a wind farm generates energy, they have to push it into the grid for distribution. And if they are not able to predict the amount of power they'll be generating or have an error outside the bounds of around 10%, then there are fines that the grid actually penalizes them with. And so with this particular wind farm, their error rates were closer to 19% when we started working with them. And we looked at the data sets that they had, again, external weather data, models of weather patterns. Historically, we pulled those. They also had a number of devices on the farm itself where we were picking up more hyper-local weather information. And clearly historical data about the wind speed, the precipitation, and of course the power output from those farms, along with the actual design of the farm itself. So the layout of the farm, the landscape, were all different aspects that we have to take into account when making these predictions. And traditional statistical methods like ARIMA, we started off with to create a baseline. And soon we were able to beat those baselines using neural network technologies. And we were able to bring down their errors closer to that 10%. We ended up at around 12 or 13%, which got them a substantial saving in the fines and the penalties that they were paying to the grid.
Yeah, I would just add, it's always interesting to us. In this case, the firm was very, very focused on their internal data assets, and and they felt like they were maxed out in their ability to predict moving forward. And what we really reinforce as a message is, your current data assets are your assets, but really it's about enriching those assets into fuel that can further optimize, your problem solving. So we sat down with them and really looked at a wider scope of the type of data that was available to them to help them, really create what we call super fuel to derive insights that maybe a competitor can't.
The next use case is in the area of chatbots. We've all interacted with chatbots, and a lot of the chatbots today are actually not that intelligent. If you think back at early versions of Siri, for example, half the time it would say, "Sorry, I can't figure out what you're saying," and it was kind of frustrating to interact with them. Today, of course, any website you go to, there's a pop-up window that comes up saying, "How can I help you?" Those are all chatbots, right? And they have a very limited ability to converse with you. We've seen Google's offering in the space, Amazon's Alexa, and of course, it's amazing what they can do today. And fueling all that, again, is this artificial intelligence neural networks that are making it much more possible to convert speech to text and to understand that text and give responses that are much better than what we would have got in the past. Now, a lot of what's happening in these chatbots, though, is that you provide a set of questions and answers, and it's really matching what you've said to a set of questions that are already being defined, right? And you can't have very open conversations with chatbots. And they serve a purpose. Today, if you call a call center, you may have a short interaction with a chatbot where the chatbot actually asks you some basic questions, and really it's a way of managing the bandwidth and allowing a human to then get into the loop. Even the chat that you have on a website through the pop-up is typically trying to buy some time before a human becomes available to actually interact with you. Now, what we worked with was with a startup based out of California, where the startup's founders were essentially linguists, and they had spent a lot of time looking at how salespeople interact with potential customers, and this was in the space of auto sales. What they had learned were these very interesting signals that good salespeople picked up. Is the customer a very visual person? And if they're talking about, using visual cues, the salesperson would then start giving them this kind of visual feedback, right, about how it would look when they were driving in their car. And, think about if they were very sensory people, then it would be more about the feel of sitting in these wonderful leather seats that the car might have and so on. And they wanted to build all of that knowledge into the chatbot. So it was not about just creating a chatbot that was, just about an average salesperson, but can we actually build something that uses domain knowledge and can utilize that domain knowledge in picking up these very implicit signals and coming up with responses where, it might be a particular mood you're picking up. You might want to pick up the driver. Why is this person walking in and wanting to buy this? Is it because, he's got an 18-year-old that he needs to buy a car for, or is it, time for him to change his car because maybe his partner is keen that, they make that change. So what is it that actually is driving them? I mean, using all of those different components of that conversation was what this project was all about. So rather than starting off with question and answer pairs, what we got was a bunch of data which was recordings of previous conversations that have taken place between a salesperson and a potential customer, and we used machine learning algorithms to come up with a chatbot, at least a first cut of a chatbot that would start interacting with the author of the chatbot. And here, the human trainer, and this is a really important aspect of machine learning and AI, is the fact that while we have data, we also need a domain expert that can tag that data and provide feedback to the early versions of the artificial intelligence to allow the artificial intelligence algorithm to improve itself. So again, here, a lot of deep learning algorithms, some sentiment analysis to understand, is the customer getting irate? If they're getting irate, maybe another model there that actually figures out, how do you try and, improve the mood of the customer or address the issue that's making them irate and try and bring them back on track within the process of actually making a purchase of the car. The next case study that we have is on adaptive learning. I kind of mentioned this in addressing one of the questions that you had asked, Julia. Here we had a company that had a platform. We've all heard of MOOCs, how they're changing the education landscape by providing superb content, the likes of Coursera or Udemy or Udacity, providing very good content to people sitting all around the world and educating them in domains where they could not possibly have got that education based on their geographical location. Now, the problem with current MOOCs is the fact that no matter what your background is, the content is delivered to you in a linear way. You have to go through every piece of content before you get to the end of the course and get a certificate saying that you are capable of understanding the concepts that have been delivered. Of course, that's very much an automation of what happens within bricks and mortar universities today, where you may have a class of 200 people and the lecturer is sitting there and teaching, and half the class is getting bored because they are getting to grasp the concepts very quickly. The other class, half of the class, is actually struggling because they aren't getting that concept, because you can't actually deliver the same lecture in different wavelengths, in a physical world. The idea of adaptive learning is that you can do that online because you have an audience of one with your student. And so the idea here is to build a model of what is the student's understanding. Are they getting proficient at certain concepts? Do they have misconceptions that need to be addressed? Can we address them with other content that's available on the platform? And you essentially chart a separate pathway through the content to deliver on essentially what the goal of education is, which is an understanding of the concepts that you're trying to teach in the best mode possible, so that the student comes out with a learning that they would have otherwise not been able to get if they were sitting in a lecture room within a university. So again, here we built using some probabilistic models a solution for our customer, which they were able to then demo to their end customers and bring to the market after we had actually developed that to industrial strength, essentially. Moving on to the next case study. This is a very different kind of example to do with agriculture. So, changing weather patterns are impacting the amount of yield within agriculture. There's a lot of indiscriminate use of pesticide in the developing world. This is some work that we are doing in India. The pests are getting resistant to the pesticides that are being used because of this indiscriminate use. A lot of that pesticide is getting to the water table and poisoning the water that is then being consumed by the population there. And what we found by working with some domain experts was the fact that often, spraying of pesticide is done on pests that actually don't actually have that much of an impact on the yield. And so in this situation, farmers not knowing any better see this pest. They buy the pesticide to spray and spray them in any case, right? And some of those are actually friendly insects that can have a positive impact on yield. So what we did there was we built up a solution where using drones, we would monitor the fields on a regular basis and find areas of distress on the farm. Once those areas of distress have been found, those were then beamed down to an app on the farmer's phone, and they could actually go to that location and take photographs that would then be automatically classified to identify what is the disease or what is the pest that is impacting the crop. Using enriched data from IoT devices that would tell us about the health of the soil, that would tell us about moisture levels, that would give us hyperlocal weather data. We are building models here to now say, when we've identified the disease, now can we actually look back and do an early detection of that disease so that we can actually nip it in the bud rather than allowing it to progress to a point where it actually becomes more visible and has had more of an impact on the yield. And this is really important for us going forward because the population of the world is growing, our need for food is growing, yet most farmers in at least the developing parts of the world are not seeing profit out of their business. So by creating this infrastructure and using a lot of the AI algorithms here, we are automating some of the advice being given to farmers so that they can actually turn their business around and actually become profitable. So I guess those were 4 of the case studies that I wanted to cover to give you an idea of how in very diverse domains we are actually being impacted by artificial intelligence. Noah, would you want to walk everyone through?
Sure. So Sarah and I spend a lot of time with clients, walking through a process where somebody comes in and says, we have a number of problems that we think we need to solve to really impact our business. And we get together usually initially in a call where we do discovery sessions to get down to the detail of the problems and work with them to kind of document that and, discover and build toward a POC. And we usually then build out the POC and bring it to users within the organization so that they can use and make modifications to a POC. Then we get into the learning process of, where the modifications need to take place. And it's kind of a 360 revolving circle for clients to be able to come in, discover what AI can do for them, and then build out a process that allows them to see the eventual positive outcomes. We've partnered with the SCRA as a resource partner, and we're looking to expose ourselves to the portfolio companies in a meaningful way and allow us to, add value to their business efforts. And typically, it comes into a number of different buckets where we can help, which is really coming in at the kind of the cradle side of things, where companies are really trying to visualize what they can do with AI and to help them form that strategy. So mapping AI to the business strategy and really looking at turning that into a map for the future. We do a lot of data discovery where we're looking at current assets of a firm and helping them think about how they could enrich or utilize those assets in deployment of AI. And, normally that looks like I have data assets, but they may be siloed. They may be in different areas of the organization that can't be utilized. So there's some engineering, some consulting, and then kind of us helping them think about how to enrich that data to be utilized for AI. The next piece typically is kind of that technology roadmap that we addressed in that previous slide, which is to sit down and understand where the business is, what their strategy is, how AI aligns to that and can modify it, and then building out really that technology roadmap with the company that says, here's my current state, here's where we want to be. Let's build a map moving forward or a technology map moving forward that helps the company to achieve the long-range goal, but get that low-hanging fruit along the way. And I think that's kind of an important piece to this, is when we work with clients, it's one thing to set out a strategy for the long term, but every company needs to see value along the way. And we work in a very agile process, and I think, the building of AI and insights and analytics into your business model is an iterative process, and it's also lends itself to really showing value in every step along the way toward the larger goal. And then our piece, with the technology roadmap after that is typically we'll be able to deliver to a client this roadmap, and then we can get involved in implementation. We have 60 folks within our organization here in the States and in India that have a diverse skill sets across the entire ecosystem of AI consulting and implementation. So we can plug right into clients and help them with their implementation. And sometimes that's in areas of skill sets that they may not have internally that they need to offset. In other cases, we act as their full implementation team.
All right. Well, thank you, Noah. Thank you, Sarah. Thank you so much for being here. We are opening the line back up for questions, and they are just pouring in. So let y'all take a sip of water, and we will get to it. So the first question here is kind of piggybacking on a previous question about cybersecurity. The question is, manufacturers recognize the value of Industry 4.0 in sharing data across the supply chain, but they are concerned with these cyber issues. Can you explain the pros and cons of storing their data on site, in the edge, or in the cloud, and how can they safely realize Industry 4.0 benefits with their suppliers and customers?
Sure. We have touched upon cyber issues in a previous question as well. I think this is a very valid question. Part of working with the supply chain is to look at how the whole supply chain is secured to make sure that the data is only being used by the folks that needs to and can deliver value in business. As far as protecting your data is concerned, and the pros and cons of being on internal servers on the edge or the cloud, personally, I think if we do follow all the norms that are made available to us within cloud service providers, it's actually a good option to have because securing it internally is a difficult process. right? And rather than just completely unplugging from the internet and keeping your data internally, which is not possible really in today's world, it means building your own cybersecurity team internally and managing that. And I think it's in my view, it's a good idea to actually outsource that to the cloud. I would definitely think that that's the way to go. How can they safely realize Industry 4.0 benefits with their suppliers and customers? I think the only way is to actually bring these data assets together and analyze them, right, and look at efficiencies that they can bring within their processes.
We see a lot of customers looking across the partnership food chain and saying, initially, can we get a cut of the data? Let's get certain pieces of the data and bring it in and aggregate it and look to see how useful it is. Then start looking at really the security and how to wrap it in a very secure way in implementation.
Great. So we've had 2 questions on cyber issues and 2 answers of the cloud. So we heard that one loud and clear. Another question has come in, and the question is, how do you cognitively use AI data to make better business decisions in education and workforce development? Can we create a virtual teacher, student, HR, or onboarding or training chatbot?
So I guess there are a couple of aspects to this. One, I don't think AI is there yet in being able to completely replace a teacher. There's a lot of good content that's out there for sure, like I talked through the use case, there are things we can do in changing the way that content is delivered to people, right, and adapt that. From an HR perspective, there is a lot of interest in HR analytics today, understanding from all the data that you're collecting about your employees, where are the deficiencies in training, building out a growth plan for your individual employees and delivering on that. There are a number of chatbots that are being developed in this space, where employees themselves can interact with them and say, in the future, I want to see myself take my boss's job. What are the skill sets that I need to develop? And to manage that career is something that is being done, but it's not fully automated. There is, a human element to that for sure, but there is innovation happening. Some of the automation of processes on onboarding new employees, that's all inherently automatable, right? And so, in fact, internally within Tatras, we actually have a chatbot that our employees interact with for all their questions on HR, right? Because these are easy to implement, and it actually frees up the time of HR to actually do more important things.
There's a lot of AI development going around the recruiting piece of AR as well, or human resources as well as looking in depth and in detail about job specific skill sets that need to be to be successful, and attaching that to the types of folks that are coming in and applying for the jobs.
Yeah, I mean, interestingly, we worked with a business that was looking to build technology that allowed for more insight than just a CV provides, right? So looking at the cultural mix, looking at where has this individual actually worked in the past. Is there evidence, a lot of CVs are geared to the job description. So a lot of keyword stuffing happens in IT, for example, right? Everybody today wants to be a data scientist, so they all have had experience or understand TensorFlow and neural networks and scikit-learn and all of these technologies. And it's really being able to assess by analyzing deeper into the curriculum vitae or the resume as to whether there is projects that they've worked on that actually make sense, right? So if somebody's created a project, is that a project that you see on all CVs? So that's really a student project that's been done on Coursera during Andrew Ng's, data science course, or is that actual experience that they've gained by working on a particular project in the real world? And if they're claiming to have used neural networks or some fancy technology there, does it make sense from the description they've provided, right? So going much deeper in there. So, just the simple keyword matching that was done, earlier by HR recruitment firms, we are able to go much deeper with AI now.
Great. Excuse me. Just as a reminder, when we are finished, a question came in asking if we can get copies of the slide deck presented, and the answer is absolutely. I will provide that afterwards. One more question about the origin or the history of AI and data. How do we track what is real, and how do we track or how do we figure out which data has been machine augmented?
Right. So, that's a very interesting question, and I don't think it has a definitive answer here. Clearly, tracking the origin of the data can be done, right? You can log where that data is coming from, where it's flowing to, what processing is being done to it. As far as machine-generated data is concerned, a lot of the time, what you would find is when the pattern gets too strong, you're seeing very obvious behaviors occurring. That is machine-generated, because the machine-generated generating algorithms, yes, they do some randomization of the data to try and fool you, but you start seeing signals that are stronger than you would see in the real world, right? And so typically when one of my data scientists come back to me and says, hey, look at this, I've created a model that's 99% accurate, I know there's a problem there, right? And rather than focusing on getting a model that's 99% accurate, really what you want to do is beat the status quo. So if currently you are getting a 2% return on your mailers that you're sending to your customers, if you're getting 4%, you should be really chuffed about that. You shouldn't really be looking for a 99% accuracy in identifying the individual that's going to actually take up the offer you're sending to them. So it's really looking at very strong regularity within the data. And if that's happening, then typically it would be machine-generated, cryptocurrencies, where we analyze data in cryptocurrencies. Very often, the order book on certain exchanges there have been manufactured, right, by the exchange themselves, because they want to try and project themselves as an exchange that has a lot of traffic on it and a lot of interactions happening. And so there, the idea is to look for patterns that are different from key exchanges that do actually have a lot of volume. So if you find very big differences in the patterns that you see in the data, it's machine generated or not.
Yeah, I think an interesting point you made, Sarah, is about accuracy and what the goal should be and how it should be. What are the KPIs associated with that? So if we're not, you come back with a model at 99% accuracy, obviously that's probably not a real world implementation. But when we look at, taking the wind farm from 19% error down to 11, it's really the business domain and the leadership of the business needs to look at that and say, monetize that. What does it actually mean to the business? And that's one of the ROI kind of steps that we take early on in the process to see, hey, we can do this. We think we can get to this level, and this is output out of maybe a proof of concept. How valuable is that to the organization? And what does it mean, to the bottom line? So I think from a management side, looking to implement AI across your business, you should be thinking about those types of questions of the AI development process.
And that's a very good point. The reason why most AI projects that fail is that people haven't thought through how it's going to impact the business. It's very important to actually get the business owners into the conversation very early on to understand what are the right KPIs. A data scientist is always going to try and strive to get a more accurate model. The business, may just be interested in a decently accurate model that moves the needle for them, substantially. So rather than, and this is where the gulf is between a data scientist and business, because they have different objectives. And you've got to keep reining the two in and making sure that what is being delivered is of business value and can be deployed within the business. So another aspect that's really important, which gets ignored a lot of the time, is, okay, once we've built this model, how are we actually going to use it? How is it going to impact my processes today? And if you haven't thought through that, the most successful data science project could be a failure as far as the business is concerned.
Yeah, and and we try to mitigate that risk by really that discovery and the planning up front with clients, is to really understand what's available, what their strategy is, and talk about and get these out on the table quickly. And the other thing I would also add is, I think a lot of business leaders will look at the data science domain and say, well, I need to find a group that has very specific knowledge to my domain. And we find that not necessarily to be the case. Don't be afraid as a business leader to go talk to a more agnostic group that really understands the discipline of implementation of data science, because the data science team, as long as you have strong domain bridges, can come up to speed very, very quickly. And it's really having that open dialogue between domain leadership and the data science leadership to make a successful project work.
Great. Thank you so much, both of y'all, for being here and providing the insight that you have shared on data, the future of data, and AI. I'd like to thank everyone that's still on the line for participating. We've got some really great webinars coming up in the future, specifically tax incentives for South Carolina-based small businesses. We have HR and hiring for millennials coming up. Check out our website to view those dates and times, etc. I'd like to thank both of y'all again, and everyone on the line, thank you, and have a great rest of your week. Bye-bye.
Thank you. Thank you.